In this video, we'll take a look at antiderivatives. An antiderivative of x to the n is x to the n plus 1 over n plus 1. This formula is valid for any real number n as long as n is not equal to negative 1. So the idea of an antiderivative is that if we take the derivative of this function here, then we're going to get back to x to the n. That works because the exponent n plus 1 will come down in front, it will cancel with the denominator here, and indeed we will get back to x to the n. So notice the notation here, we're using little f for our original function, and we're using capital F for the antiderivative. Let's try an example. We'll find an antiderivative of 12x to the fifth. We'll write our antiderivative as capital F of x, and if there's a coefficient like 12 in the term, we're going to leave that in front. The antiderivative of x to the fifth, we're going to increase the exponent by 1, so it becomes now x to the 6th, and we're going to divide by that new exponent, which is 6. And then finally we can simplify 2x to the 6th will be an antiderivative for that function. So just as a little mental check here, if we take the derivative of this term here, indeed we do get back to 12x to the fifth, so that works. Now just a little comment here, there are other possibilities. If we took capital F of x, which looked like 2x to the 6th, plus any constant, so any real number here, that would also be an antiderivative for 12x to the fifth, because when we take the derivative, the constant's going to disappear. So I'll say, in general, an antiderivative would have this form, but in this introductory video here on antiderivatives, we're just going to be looking for the simplest possible antiderivative. So we won't worry about the constant just yet, but it will become an important idea later on. Part B, let's find an antiderivative of negative 4 over x cubed. First thing we could do here is rewrite our function. If we like, we could think of that as negative 4x to the negative 3. For the antiderivative, we're going to leave the negative 4 out in front. The exponent is going to increase, and if we're talking about a negative exponent, that exponent is going to become less negative. So it's going to become x to the negative 2, and then we'll be dividing that by negative 2. So overall, we've got 2x to the negative 2 will be one choice of an antiderivative for negative 4 over x cubed. To find an antiderivative of this function, let's leave the 7 in front. And we're going to increase the power on the x by 1, so that's now going to become 7/2. And then we like to divide by that exponent. Now, dividing by a fraction is going to result in multiplying by the reciprocal of that fraction. So in general, if you're going 1 over any fraction, a over b, what that's going to produce is b over a. So when you've got a fractional exponent like 7 over 2, instead of writing it as over 7 over 2, it's faster just to multiply by the reciprocal of that fraction there. So simplifying that, we've got 2x to the 7/2. Now let's say our function is 2 times the cube root of x. Let's rewrite f of x, as, if we like, as 2x to the 1/3. And that way we can calculate our antiderivative as 2 times. Now we'll take the antiderivative of this guy. The exponent is going to increase by 1 to give us 4/3. And instead of dividing by that fraction there, we're going to think of it as multiplying by the reciprocal of that exponent. So simplifying now, we've got 3/2 times x to the 4/3. Now let's say we want an antiderivative of the constant function 2. Well, formally, if you like, you can think of this as 2 times x to the 0, and our antiderivative now will be 2 times x to the 1 over 1, which we could write more briefly as 2x. So really good to remember just how to do this quickly. If you want the antiderivative of a constant function, you're going to be creating that constant times x. Let's find an antiderivative for a polynomial. To get our antiderivative, capital F, we're going to find antiderivatives one term at a time. So we'll have negative 5 times x to the fourth over 4 plus 9 times x cubed over 3 minus 6 times x squared over 2, and the antiderivative of any constant is just going to be x times that constant. So we'll have plus x here, and then finally we can simplify. Minus 5 x to the fourth over 4 plus 3x cubed minus 3x squared plus x is our antiderivative.